The second presentation this afternoon is from Florian, Delta Fox 2 Echo Tango. He will introduce us to digital narrowband operations on Quebec Oscar 100. But let me first introduce Florian. Florian, his call sign is Delta Fox 2 Echo Tango. He received his radio amateur license in 1999. He's QRV in many digital modes, especially on VHF, UHF, like DMR, and he's actually a co-developer of the DVM hotspot boards. He's QRV on QO-100 since its launch and has been a very active supporter of the Delta Papa Zero Golf Victor November station in Antarctica. For 2 months, he is now also active on the LEO satellite, mostly SO50, AO91, 92, RS44, the Chinese satellites. And in his spare time, as a hobby as well, he's a volunteer firefighter. And being an experienced firefighter, he helped us firefighting the short-term changes of this symposium because, as I mentioned before, early this week, we had to set up the online symposium completely remotely because it was no more possible to travel to Bochum. And Florian had some initial experience with Zoom. And in the last few days, he was instrumental setting this all up. And he's managing today the symposium and switching between the presentations. Thank you very much for this, Florian. And now we are curious to learn about digital narrowband operations on QO-100. Please go ahead.
Yeah, okay. Good morning, good afternoon, good evening, everyone. Best regards from the control back room of this AMSAT Symposium 2020. I'm happy to have a short introduction to digital narrowband operations on QO-100. And I will keep the time, as Charlie was a little over, but we'll manage that to keep the time plan after on, so that everyone can see what he likes to see from the following presentation. So what I prepared is some information on digital narrowband operations on QO-100. As you know, most of you are on air in sideband and CW, also some slides operations in FT8, FT4, some RTTY, some SSTV and stuff. But what is not so very popular is what I focus on in this presentation is digital voice operations. And as you know, the broader operation modes like D-Star, P25, and whatsoever is in use on UHF and VHF is not according to the band plan on QO-100. So we had to look for a different alternative. And this is what I would be about. As a short introduction, I'm showing you some hardware and software options. And what came into this presentation just a few days ago was while we were preparing this online symposium, was some great news by one of our members, DJ0ABR, Kurt, who is developing some digital data transfer modes with higher speed rates than we have currently, but we'll come to that at the end of the presentation. So, as I said, most of the voice operations on QO-100 currently happening are a single sideband and maybe CW. As I said, the digital voice modes are not according to the time plan, although possible, but not really using the power budget effectively. So there was in the beginning some people experimenting with D-Star, which worked, but yeah, as I said, not according to the time plan. We see also some minor activities in digital modes like KG, SSTV, RTTY, FT8, FT4. And of course, there's CW to be mentioned, as we had 3 alpha on the transponder. from yesterday on. We also see some quite heavy pileups in CW. I like CW. I had the chance to work Felix Delta Lima 4 X-Ray Lima from DP0 GVN in Antarctica the first time in CW. So I was trying hard to learn CW for a year until I finally managed my first QSO with Antarctica. But digital voice operations on QO-100 is possible, and also possible with regards to the band plan. There is FreeDV, as most of you might have heard of that before. It is mainly used, or was mainly used, on HF. As I personally do not have any options to put up HF antennas, that wasn't any playground for me up to when QO-100 launched. And I had a look at that as I support open source software and development. So FreeDV is one of the examples, completely open source, no copyrights, nothing to fear of, to be punished while using some closed source stuff. And what I also like about that is that the client or GUI is available for major operating system. I am a Linux fan, although I have to admit for this online symposium, I had to reinstall my machine here that is running the control now completely to a Windows 10 that will be wiped straight after this online symposium to get rid of this Windows stuff again. So we have a client, well, the FreeDV client, of course, is available for Windows as well, but I'll try to keep the focus on the Linux version. From what existed prior to QO-100 was that FreeDV offered several modes that can be distinguished by used bandwidth and audio bandwidth. There is the 700D modes and 1600. I'll come to that later in detail, but what we have on QO-100 now with the latest developments is the so-called mode 2020. Which is able to provide an 8 kilohertz audio signal in just 1.6 kilohertz RF bandwidth. So perfectly fits into an SSB channel, and thus also compliant with the QO-100 band plan. It's the preferred mode for QO-100 operations to know. There have been some minor developments lately to that to make it possible to use on QO-100. So if you see and hear any FreeDV signal with your SSB transceiver, it's most probably FreeDV 2020. So the software. This is a screenshot from the Linux client that you can use for FreeDV operations. As I said, completely open source and available for all major Linux distributions, also available for compiling from source. The main window shows the RF spectrum. You can have different views. You can also view the audio spectrum. And so on, but the initial view is the RF spectrum on air. You have various controls besides the window on the left-hand side and on the right-hand side. I'll come to that in a minute. And there's also a display that shows you the signal-to-noise ratio as well as the bit error rate on the left. So you have a complete control over your audio signal as well as the RF signal with this nice client here. You have to choose the mode that you want to operate on beforehand. So currently there's nothing like an auto detection for the mode that you would like to use. So you have to select that before operating. As you can see, there is the mode 2020 at the bottom. For Linux systems, this is just available if you have specific CPU features built into your CPU when compiling it, but all recent computers should be able to operate the FreeDV 2020 mode. Otherwise, it's just grayed out. If it's grayed out on your system, you should pay attention to this CPU flag stuff. If you selected the correct mode, you have a separate control panel located below the mode selection. And you can start or stop this FreeDV DN encoding. You can also activate the analog audio output input and the voice keyer. And then there is the main button just below is the push to talk button. What is currently missing from my point of view is a PTT control from, let's say, a serial port or stuff like that. So you would have to push and release the transmissions in FreeDV using a button on this application. On the left-hand side, as I said, some controls showing the signal to noise ratio on the top left. Then there is a resync button. From time to time, it happens, especially if people on the transponder are not really locked to some stable frequency source. You see the signal slightly drifting left and right. You can, or you might have to use the resync button to resync the signal so that the FreeDV software is properly decoding the stuff again. And there's a lot of statistics just below. You can see the bit error rate, how many bits are transferred, and so on. So if you encounter that the error counter is increasing rapidly, you'll have to make sure that the audio spectrum is clean and no issues on the audio pass between transceiver and computer, and that you're properly synced. The second, or maybe to be prepared before, oh no, I forgot something. Besides the voice transmission, there's also a slow data rate channel transmitted on the same signal. So a little bit comparable to D-Star transmissions, where you have you can add a, I don't know exactly, 20-character message that is transmitted with all of your overs. So in this case, it's showing a text message that was transmitted by my QSO partner DJ4RAM Sharam, who was so kind as to test with me the FreeDV stuff on QO-100. Then I'll step over to an issue that I stumble across various times while supporting people getting QOV on QO-100 on FreeDV. The thing is, you need at least 2 audio devices. Why? The one audio device is the interface to the operator. Let's call it that way. So it is encoding the audio that you put into the microphone and decoding the audio sent to your headset, for example. So, and the other one is the interface between the computer that does the DN encoding and the transceiver. So there's one audio path on the left-hand side, taken some screenshots from the config menu. The audio path is from your transceiver to the computer, and from the computer further on to the speaker or headphones. So that's 2 devices that you can see on the left-hand side that are some devices listed on my Linux system, for example, that you have to pick the devices according to your configuration. On the left, on the right-hand side, it's the other audio paths going from your microphone or headset into the computer. On the top part and on the bottom part, and the audio device that you need to select for the audio paths between computer and your transceiver. So that is a little bit of confusing, especially people usually stumble across the naming here in the FreeDV config. But once you figure out that it's 2 more or less independent audio paths via 2 sound cards or 2 sound devices, you should be able to solve this problem. And then, of course, you need to select some devices for your PTT control. In this case, as usually known, and also works with the recent transceivers that are commonly used on QO-100, like the 97000, is the PTT control via just a pin on the serial port. There are other options with left channel Vox tones or using the ham lip. But as I show my configuration later on, in this case, it's a 9700 connected and just using a PTT that is controlled via the serial port. So this is what there was about for the software. So basically just a client to install, do some configuration, and you should be more or less ready to go. If you set the correct PTT configuration and if you selected the correct audio devices. If not, start from the beginning and try to determine the correct audio devices. Then a little view on the hardware. So there are two solutions. One is, I did call it software solution. So the whole FreeDV stuff is done in software on a computer. In this case, I said I'm operating a 9700, which is a very nice audio for this case because it just requires a single USB connection to the transceiver, which carries a virtual audio sound card that is built into the transceiver and also has two serial USB serial devices that you can configure, for example, to control PTT. So in this case, no fiddling around with what we had in the past with some external sound card having a separate USB to serial adapter or even a serial port with a transistor to control PTT. In this case, very convenient, just the USB connection to the ICOM 9700. This allows you to use all the modes that are available. I'll come to that later on, showing you the what I call hardware solution. So you can even use the FreeDV 2020 if your computer supports that mode. There is a drawback on Linux that you have to compile it yourself with the corresponding options, and you have to have a decent CPU for that, but should be available in most of the cases. As I said, just use one USB connection between the computer and the radio, but you would need a computer for this solution to operate because, as I said, FreeDV DN encoding needs to be done. So in this case, it's done in the software. I was searching for a solution that is more or less portable, and did find a nice device that is developed by the authors of FreeDV itself, called the SmartMic 1000, a little audio device with an SCM CPU and some also open source software on that. That you can use for FreeDV encoding and decoding as a somewhat hardware solution. So you just need to wire up your transceiver to this device. You can use it as more or less a hand microphone if you wish to. There's a little push to talk button on the side that's shown here. There's a speaker built in and a small microphone, but there's also a connector, of course, to connect an external headset or PTT to this small device. So this is a solution that you can use as a hardware solution if you don't want or cannot use a computer to operate the FreeDV modes. The drawback is that as of now, the SmartMic does not support the FreeDV 2020 mode, although it's very nice to operate in 1600 or 700D, which still produces nice audio, but currently no support for FreeDV 2020. Not sure if there's more hardware to come. I would be looking forward to that, to have a nice small device for hardware and decoding for FreeDV. But this solution does not require a computer, so you can just use this device as a FreeDV modem, for example. So my setup at home is just an example of what I operate is the mentioned IC 9700 with, in this case, some converters located here. And there's just, as mentioned, this single USB connection to the computer running the FreeDV client, controlling PTT with the little button on the application interface here. And in this case, running a headset for audio and microphone. And in this case, just an example, my 80 centimeters dish on the balcony running the Kune DV6NT down converter with the Barmatech dual band patch feed on the balcony. I'm a very lucky person because QO-100 is just 1 degree off the buildings on my balcony. So I was very lucky to have this possibility to work QO-100 for my home QTH here. So we'll come to the end of this short talk about digital narrowband voice operations. And now I have got some slides that came into my presentation just a few days ago because this is under high and heavily development by some of our members of AMSAT Germany. Which is especially Kurt DJ0 ABR, who is working on some digital data transfer via QO-100, not via DVB-S2 or stuff like that on the wideband transponder, but to have some sort of digital data transfer on the narrowband transponder. What we were thinking about is having some other stuff as the current beacons to transmit some maybe DX information or recent news or whatsoever, and be able to distribute that on the narrowband transponder. What also might be in scope, but as far as I know, nobody tried yet, but would also be a good option is data transfer on the wideband transponder. But as I said, not in scope of what Kurt is currently operating on. So he did some developments, sending and receiving data with QPSK modulation on the narrowband transponder fitting into an SSB channel. And this is just an example of a piece of software that he wrote. You can see a nice picture here with comparably high resolution that is sent via the narrowband transponder. And as another example, this is a plain text transmission of the source of an HTML formatted document. In this case, as an example, to show, for example, some recent DX cluster messages or news from, in this case, the online symposium that could be transmitted on the narrowband transponder with this digital data transfer mode developed by DJ0ABR. And he also provided me a source, a similar table of a comparison of these modes that he's working on compared to what we have now. So, for example, in this case, the analog SSTV, I'm not sure which mode he chose, but usually a transmission time for a comparably slow resolution of a picture compared to what he is developing with QPSK modulation. So roughly the same size transmitted in less than a quarter of the time that we need for the SSTV pic transmitted in digital, while the SSTV is basically analog. And also allowing for higher resolutions like 640 by 480 in this case, that is still just 2/3 of the time that we use for a half of the resolution for an analog SSTV picture. And this mode would allow for also not just transmitting binary data like images, but also, as mentioned here, text transmissions like DX information, or even, as shown in the picture before, some basically HTML formatted text documents with embedded pictures or stuff like that. And what is also facing is to develop the software for all major operating systems. It's definitely open source and will be available for Windows, Linux, and Mac clients here. He also provided some examples of pictures that I took to my presentation. So this is what is available right now. Analog SSTV pictures with rather low resolution. The alternative is KGSTV with transmitting the same picture size in digital transmission. And this is his picture that he transmitted in less time and even with more or less double the resolution. So quite interesting to watch this development, and you should definitely keep an eye on that. We are aiming to provide open source on the GitHub repository of AMSAT Germany as soon as that's usable. So that is the end of my presentation. Thank you for your attention. And I'd say back to Matthias. Thank you very much.
Thank you very much, Florian, for this very interesting presentations. Also, I think it's a good outlook that hopefully soon we can also enjoy the new digital modulation schemes. I think that the target from Kurt is to provide the software by end of the year. And let's see how he's progressing in the next couple of weeks. There is a question on the YouTube channel. One question is from Frank, Delta Lima 2 Golf Radio Foxtrot. What is the current center of activity on FreeDV in terms of the frequency on QO-100? Florian, you're on mute.
Yes, I unmuted myself. Thank you very much for that question. So we usually experiment with FreeDV in the area for the digital narrowband band modes, which according to the band plan is in the area of 0.600. So you should keep an eye on that area of the transponder. If you see a steady, what looks like a steady carrier, which is in this area on the transponder, you may be able to decode FreeDV there. I think it's, I'm not sure, is it 640 or 620? Not sure about the exact frequency.
I think it's 640. Yeah.
640, I guess. Yeah, right.
Yeah.
So if you see a steady carrier in the 640 area, you could try to decode FreeDV there. Although, as I said, you need to set the mode. There's no auto detection of the modes, but I would start with FreeDV 2020, which is most likely to be in use there. And if that doesn't decode, you could try 1600 or 700D, but it's most likely 2020.
Yeah, okay. Thank you very much, Florian. I think there's no more questions. A lot of compliments also on the chat room for you, Florian. Very interesting.
Thank you very much, guys.
Thank you very much.